I want to take this other time to welcome you for yet another video on my YouTube channel, which is called Ripo's Lectures. But the channel link is written below. You will check it, and then please don't forget to subscribe. Don't forget to like my videos. Don't forget to comment to my videos. So, for the purpose of today's lecture, we are going to talk about fluid mechanics, the concept of fluid mechanics. So, and fluid mechanics is a very powerful concept as far as engineering is concerned. So, fluid mechanics by definition is the science that deals with the behavior of fluids at rest or in motion. So, it deals with the behavior of fluids at what? At rest or in motion. And that's why we're going to cover at rest is going to be hydrostatics, in motion is going to be hydrodynamics. You get? So, at rest, hydrostatic, because hydro stands for water, static stands for rest. Then hydro stands for water, dynamic stands for motion, moving. So fluid mechanics shall be dealing with fluids at rest and fluids in motion. So, but what's a fluid by definition? As we're going to be covering in our constitutional lectures, we are going to know that a fluid is a substance which is either in liquid or gaseous form. So a fluid is a substance which is either in liquid or gaseous form. So all through the lectures of fluid mechanics, we'll be talking about fluids, gases, sometimes solids and oil. You know that. Under liquids, we can be having oil, we can be having paraffin, and so forth and so forth. But just master the fluid is a substance which is either in liquid or a gas. So fluid mechanics, we talk about rest and motion. We're talking about the science of study of the behavior of fluids at rest or in motion. And as I told you, is hydrostatics. In motion, it is hydrodynamics. We will cover them step by step. So the outline is this. I have around 4 chapters. The first chapter is properties of fluids. The second chapter is hydrostatics, which is study of fluid at rest. Then the third chapter is hydrodynamics, which is the study of fluids which are in motion. Then the last and of all, we're going to cover dimensional analysis. We should talk about the model and the prototype. But the course outline of this fluid mechanics, it varies from university to university. It varies from program or course to course. So please take it from me. If you want other interests, you can comment below in my comment box. As you comment, you can tell me you can do this. Please add on this on the outline. I will do so. Please just comment what is missing. But under properties of fluid, we shall be covering density. Density is also known as mass density. We shall cover specific weight or weight density. We shall cover specific volume. We shall cover specific gravity or relative density. We shall cover the concept of viscosity. We shall cover there are very many properties. There is also surface tension. There is also specific energy. There are very many properties of fluids. But for purpose of this lecture, we shall cover only a few. Under hydrostatics, fluids at rest, we shall cover pressure, the concept of pressure, manometers. There are very many types of manometers. We shall cover all of them one by one. Then we cover also pressure, force on a plane surface. We shall cover pressure, force on a curved surface, and flotation. Flotation, we shall be talking about buoyancy. When they throw an object in water, it can float. Then we also have the concept of hydrodynamics, which is the fluids in motion. We told you fluid mechanics is study of fluids at rest and in motion. At rest is going to be hydrostatics. In motion is going to be hydrodynamics. So hydrodynamics, we shall cover the energy equation, which is basically the Bernoulli's equation. We shall cover the basic formula, how to derive it. Then we shall also cover the application. The primary application of this equation, we shall cover all of them. Then we shall also cover the momentum equation, of which in the momentum equation, we shall cover its principle and the application basically. Then the last we shall cover dimension analysis, models, prototypes. We shall cover very many things under this. So please don't forget to like, comment and subscribe to my videos, because they'll be worth taking and worth watching. So for today's lecture, I want to take this time and introduce for you the first chapter, which is properties of fluids. So the first chapter we're going to handle is going to be properties of fluids. So I told the properties of fluid are very many. There are too many. There are very many properties. There's viscosity, specific weight, there is specific gravity, specific volume, density. There are very many. There's specific energy, there is surface tension. So I'll cover a few for the purpose of this lecture. Density, we all know that density is the mass per unit volume. So that means per unit volume is going to be mass over volume. You get? So when it comes to specific volume, it's going to be the volume per unit mass. So since density is mass over volume, then now this is like the reciprocal. You know, we find that it's the reverse of this. So that means it can be 1 over density. The unit of density is kilograms per meters cubed. When it comes to specific gravity is also known as relative density. Relative density is the ratio of the density of a substance to the density of pure water. So that means what's known as specific gravity. The formula is the same as relative density, which is density of a substance over density of pure water. Now, since density and density they are the same, the ratio of the similar substances, that means the specific gravity has no unit. Because here it will be kilogram per meters cubed, even down will be kilogram per meters cubed. So when they cancel units, so you find that specific gravity has no unit. So I want to tell you that under specific gravity will be a very important formula they're going to be using when it comes to our pressure, to our hydrostatics. So also the next concept is specific weight. Specific weight is the weight per unit volume. So it's weight over volume. So the weight, so weight is the same as mass times gravity. So mass over volume is density, which you can see it's now going to be rho. This rho stands for density. Then G. So now our specific weight, which is given by this symbol, is the same as rho G. So that's the formula. So also this one also will be used so much when we come to hydrostatics under pressure specifically. So the unit of specific weight is Newton per meters squared. So and lastly, under the properties we are going to cover for this lecture is going to be viscosity. And viscosity is a property of a fluid which offers internal resistance of a fluid to motion. So under viscosity, you find that there is that resistance to motion. So and that's why when it comes to drilling of oil, viscosity finds an application in drilling of oils, and when it comes to automobiles, when you come to maintain the automobiles applications. So you can master from today that under viscosity, the applications we have: number one, drilling of oils using the concept of viscosity. Number two, we are going to maintain the performance of automobiles using viscosity. So those are applications, but also maybe to take you back, when it comes to fluid mechanics also has very many applications, but a few of them I'm going to give. Fluid mechanics has application in boats. The application of fluid mechanics we have what? Is applied in boats. Number two, the application of fluid mechanics we can also have in aircrafts. We can also have in aircrafts. Then maybe also cars. You know, fluid mechanics, we say that fluids can either be liquid or gas. So a boat will be sailing in water. So as the boat sails in water, there will be the velocity of the what? Of the water going inside. So as the boat, for example, let me use this illustration. If the boat is going inside in water, this is the velocity of the water pushing the boat. So that means behind the boat there will be a drag force. So that drag force is to pull out the boat. That's why it finds an application in boats. Aircrafts, also you know aircrafts when they are flying in air, you find that the velocity of air will be like pushing the airplane, and then there will also be a drag force behind it. The drag force. So application of fluid mechanics you have applied in boats, aircrafts, cars, and so on. There are many applications. I can refer you to books like Arake Banke, Fluid Mechanics by Arake Bansel. You can just go and look for more things to understand there. As I told you, there are many properties of fluids. Others are mentioned for this lecture, but you can comment below and then tell me which property you wish or you like for me to handle.